Hi, welcome back to this channel. In the previous session, we had a discussion over the group 17th elements. What are the properties are there and all that. Under that group 17th elements, we have discussed the atomic properties, considered as a general property, next physical property, next chemical property and all that. Next, the very important concept under the halogens is, or group 17th element is compounds of group 17 elements or halogens. The very important compounds of halogen is chlorine. It's a known molecule, the chlorine. Let us discuss about the chlorine. First compound, chlorine. The chlorine, it is represented or it is exists in the form of Cl2, diatomic state. This Cl2, chlorine, was discovered by or give the idea about the chlorine. It was given by Scheele in 1774. During the experiment with manganese dioxide, when manganese dioxide is MnO2 is react with HCl, okay, hydrochloric acid. When manganese dioxide react with hydrochloric acid, it liberates a gas, a yellowish gas is liberated. That gas is a chlorine. But Scheele could not explain the name and elementary nature of the gas. After the several years in 18th century, David explained or give the elementary nature and the name. Name was given by David. Okay, so Scheele just introduced the compound. After that, David was give the name. The name is chlorine. Okay. Next, what are the preparation method of chlorine? Preparation methods of chlorine. Preparation of chlorine. Chlorine is prepared using several methods. In a laboratory method, the very useful method is from manganese dioxide. What Scheele explained during in their experiment, the same thing is introduced in case of a preparation of a chlorine. The manganese dioxide is made to react with hydrochloric acid, then it gives manganese chloride, as well as chlorine gas. Chlorine gas is evolved and water molecule is evaporated. Here we observe the two atoms of oxygen, therefore we should multiply 2 to the water molecule, and here we observe the 4 hydrogen atom and 4 chloride atom, therefore 4 HCl. So this is the balanced chemical equation of preparation of chlorine. How chlorine was prepared? Manganese dioxide made to react with hydrochloric acid or the solid manganese dioxide. On the solid manganese dioxide, dropwise hydrochloric acid is poured. Then the yellowish gas is evolved. That gas is nothing but chlorine. Okay, this is the laboratory method. If the hydrochloric acid, the quantity of hydrochloric acid is less, or we have a lot of sodium chloride, then also there is a possibility of preparation of chloride or chlorine from manganese dioxide. Okay, again from manganese dioxide using sulfuric acid. How? When manganese dioxide is made to react with sodium chloride, NaCl and H2SO4. In place of HCl, we use sodium chloride and sulfuric acid, then it gives manganese chloride, again it gives manganese chloride and chlorine gas evolved, and again water molecule evaporated, or whatever the product we observed in the first case, the same product is observed. In addition to that, there is another product that is nothing but a sodium bisulfate. Sodium bisulfate is formed. Then how to balance this reaction? How many chlorines are there? There are 4 chlorine, therefore 4 NaCl, Cl2, Cl2, 4 chlorine atom, 4 chlorine. Next, how many sodiums are there? There are 4 sodium atom. Here multiplies 4 sodium. Because of this 4 quantity of sodium bisulfate, we should multiply 4 for the sulfate. In this case 4. How many hydrogen now? 4 into 2, 8 hydrogen is there. Now only 2, therefore you should multiply 4. How many oxygen now? 4 oxygen. Here how many oxygen? Only 2. Multiply. Okay. Here we observe the oxygen. 2 into 2. So now the reaction is balanced, I think. Cl2, Cl2, 4 Cl2, 4 Cl2, 4 Na, 4 Na, Mn, Mn. Next. Okay, here we should multiply. Now the reaction is balanced. Okay, so this is the balanced chemical reaction equation for the preparation of chlorine. Okay, chlorine gas is evolved here also. This chlorine gas also prepared using in other different methods. These other different methods are known as a manufacture of chlorine. Okay, the manufacture of chlorine, not only that one, there is another substitution reaction is there for these 2 cases. Okay, if in the laboratory there is a absence of, or there is the lack or lesser quantity of manganese dioxide, then we also use there is a possibility of using the KMnO4 also. Okay, using KMnO4, potassium permanganate also, the chlorine gas is obtained. Okay, so these are the laboratory method. This one is not important. The first one is the very important. Okay, this reaction was explained by Shiga. Okay, therefore this reaction is very important. The first reaction is very important for your exam point of view. Next is manufacture of chlorine. Okay, manufacture means industrial level preparation. Manufacture of chlorine. Preparation is simple preparations are used in laboratory. So these are the laboratory method. If we need a large quantity of chlorine, then we go through the manufacture method. That process is considered as a manufacture. Under the manufacture of chlorine, we observe 2 different methods. One is Deacon's process. Deacon's process or method. This one is the very important process for your exam point of view as well as for your competitive exams. Okay, so this is a very important answer. Deacon process of preparation of chlorine. Here just oxidize the hydrochloric acid. Okay, so then we get the chlorine. Hydrochloric acid is oxidized in presence of copper chloride, as well as we need 773 Kelvin, around 773 Kelvin. It is not exact, 740 to 773 Kelvin amount of temperature is needed for this purpose. During this case, chlorine is evolved and water molecule is evaporated. Here we should multiply 2 hydrogen. Okay, sorry, 2 oxygen. Okay, now it become 4 hydrochloric acid, 4 molecule and 2 molecules of chlorine. So this is the balanced chemical equation. Chlorine gas is evolved. Aqueous or liquid state of hydrochloric acid, gaseous oxygen. The oxygen is taken from atmospheric. The air is passed or oxidation of hydrochloric acid that gives chlorine gas or chlorine gas is obtained, and this is the liquid state water. So this is the another method or manufacturing method of chlorine. The large quantity of chlorine is obtained in this method. Therefore, it is in case of manufacture of chlorine, we use this process. That process was explained by Deacon. Therefore, this process is known as Deacon's process. It is nothing but oxidation of chlorine. Oxidation of hydrochloric acid. Okay, chlorine is obtained. Next, second process is or manufacturing process is from electrolysis. Electrolysis. The same process you already studied in your first year hydrogen topic. The electrolysis of brine solution. Electrolysis of brine solution. And what is the meaning of brine solution? Brine solution is nothing but aqueous sodium chloride. The aqueous sodium chloride is subjected to electrolysis. In one side chlorine gas is evolved and another side hydrogen gas is obtained. So this is the another method. This electrolysis process is not much important. You just go through your first year part and you get all the things about the method of manufacture of chlorine. Okay, so this process, Deacon process, is a very important part for your theory exam. Okay, the reaction is also very important. So it is nothing but oxidation of hydrochloric acid. Okay, next, properties of chlorine. Okay, properties of chlorine. Properties of chlorine. Under the properties of chlorine, there are two types of property. One is physical property. Under physical property, what is the state, what is the solubility, what is the melting point, boiling point, and all that. So all these belongs to physical property. When you observe the chlorine gas, chlorine exists in the form of a gas. The color of chlorine gas is yellowish color. Okay, yellowish color gas is observed. The boiling point is very low. Because of that, very easy to liquefy the chlorine gas. When we liquefy the chlorine gas, it becomes yellowish green color. Liquid solution or liquid is obtained. Okay, because of low boiling point. Then therefore very easy to liquefy the chlorine. Okay, next is solubility. So it is easily soluble in water. Easily soluble in water. So this chlorine gas shows solubility in water. Okay, it is existing or exhibit the yellowish color property, and also it is soluble in water. The next is it shows a pungent odor. It has pungent odor as well as suffocating nature. Suffocating nature. What is the meaning of suffocating nature? The same thing. Pungent odor and suffocating nature is you are already practiced or you are well known about this nature of chlorine during your lab analysis of chlorine or chloride radical during your lab study. Okay, during the second group acid radical analysis of second group acid radical, at that time the salt is treated with acid, the gas is evolved, correct? So it is actually hydrochloric acid. So but small quantity of chlorine is present with that, or concentration of chlorine is very high at that time. During that cases, it gives the suffocating nature. Suffocating means when we inhale the gas, it gives to produce a cough in case of the human beings. So that is suffocating nature. And pungent odor. Pungent odor means we can't inhale excess quantity of a gas. Okay. So this is about the physical property. Next is chemical properties of chlorine. Okay. Very important things under chemical properties are reaction chemical properties. The chlorine shows different types of chemical properties as similar as that of sulfur dioxide. So large quantity of a in large area we observe the reaction because of their multiple oxidation state and affinity to react towards hydrogen. So because of that, chlorine has ability to react with organic substance as well as inorganic substance, and it has ability to react with the metals as well as non-metals. So therefore, in almost all area we observe the reaction of the chlorine. Therefore, chlorine is the most important compounds under halogen. Okay, let us discuss about the chemical properties. Okay, under the chemical properties, the reaction of chlorine is, the first thing is oxidation state. Oxidation state is, it shows -1 oxidation state, -1 oxidation state, next +1, +3, +4, +5, +6, +7 oxidation state. So there are multiple oxidation states are there in case of a chlorine. Okay, next is reaction towards different elements. When chlorine has ability to reaction with the chlorine has ability to react with organic substance, organic compounds. For example, or hydrocarbon as hydrocarbons, particularly hydrocarbons. Okay, so whenever chlorine is react with hydrocarbon, when hydrocarbon, and consider CH3 CH4 is nothing but methane, react with chlorine, it gives methyl chloride, correct? So methyl chloride is produced. Again methyl chloride react with chlorine, it produces dichloride, methyl dichloride. Again methyl dichloride react with the chlorine, gives methyl trichloride. Last one is carbon tetrachloride. Okay, excess of chlorine, when excess of chlorine is made to react with methane, then it produce methyl tetrachloride. So same reaction already, sorry, not methyl tetrachloride, is nothing but carbon tetrachloride. The common name of the compound is carbon tetrachloride. At the last we obtained the carbon tetrachloride. So the same reaction we are already studied in a first year hydrocarbons topic. Okay, so this is the reaction towards hydrocarbon. Similarly, in all alkene, all hydrocarbon has ability to react with hydrogen. This is because of affinity towards the hydrogen. Okay, what is the reason of chlorine react with hydrocarbon? Because of chlorine has ability to, or has affinity to towards the hydrogen. It has ability to take hydrogen from organic compound. Therefore, byproduct is HCl are formed, hydrochloric acid is produced. Okay, so this is the chemical first chemical reaction, reactivity, under reactivity. Okay, next it has ability to react with the bases. React with the bases. The chlorine react with base, produce different types of compounds depending upon the capacity of the base and the concentration of the base. If the base is dilute, it produces different compound. If the base is concentrated, then it gives a different compounds. Okay, let us discuss about the reaction with base. This is the very important concept for your exam point of view. Okay, very important for your theory exam. This part is the very important part. Most of the cases, the question is asked based on this reaction. Okay, let us discuss about the reaction. Sodium hydroxide when sodium hydroxide react with chlorine, if the NaOH is dilute, in case of dilute sodium hydroxide, chlorine react with dilute sodium hydroxide, it produce NaCl. One side it is NaCl and the byproducts are sodium oxychloride and other products or byproducts are water. Okay, so this is the reaction. Let us balance the reaction. Sodium hydroxide, there are two chlorine. Okay, two chlorine. To balance this reaction, how much quantity of water is used? Here we use two molecules of hydrogen, atoms of hydrogen. Therefore, we should multiply 2 in this side. What happened when we multiply 2? The 2 NaOH react with the chlorine to produce sodium chloride, NaOHCl and H2O. It is nothing but sodium oxychloride. Okay, sodium oxychloride, sodium chloride. Okay, here the reaction, suppose if we consider concentrated sodium hydroxide during the reaction, but the reaction taking place in a cold condition, suppose reaction taking place in a cold condition, then also it produces sodium oxychloride. Okay, so this is the one type of reaction. Next, if we use sodium hydroxide large concentration or in a hot condition, okay, large concentration of sodium hydroxide or in a hot condition react with the chlorine, it produce sodium chloride. Okay, these two reactions are very important. Okay, sodium chloride plus sodium chloride and as well as water. Okay, here we observe sodium chloride. Okay, the name is sodium chloride. Okay, that is the difference between these two reactions. Next, how to balance this reaction? 2 sodiums is there and 2Cl, O3 plus 1. How many oxygens? 4 oxygen. Okay, therefore first you multiply 4. If we multiply 4, then you should multiply 2 and 2. It has not happened. Correct? So 4 means here I am multiply 3. 3Cl and plus 1, 4. Now it become 2. Next, okay, number of hydrogen, 4 into 1, 4. Okay, therefore I multiply 2. When we multiply 2 in this case, 3 oxygen, 2 oxygen. How many? 5 oxygen. Here only 4 oxygen. So I make it into 5. When I make it into 5, next number of sodium also get changed. It become 4. Next it become changed. It become 3. 3 into 2, 6. 4 plus it become 1. So therefore it become 5. When it become 5, it becomes 6. Why it becomes 6? Sodium, 5 sodium plus 1, 6 sodium, 6 sodium. 6 oxygen, 3 oxygen. Here again 3 water molecule, 3 oxygen. 3 into 2, 6 hydrogen, 6 hydrogen. Reaction get balanced. Okay, otherwise you should remember the reaction. There is no other way, using trial and error method or by remembering the reaction. You should get the ability to write the reaction in your exam. Okay, so these are the two important reactions we come across under the chlorine. Okay, how chlorine is react with dilute or cold NaOH, how chlorine is react with concentrated or hot NaOH. So these two are the very important reaction under chlorine. Next, during the reaction with the base, we saw another one reaction with the base. Okay, same. When calcium hydroxide is oxidized with the chlorine, then it produce bleaching powder. Okay, it produce bleaching powder. The combination of bleaching powder is calcium chloride, calcium oxychloride, calcium hydroxide. Small quantity of calcium hydroxide remains as a calcium hydroxide plus 2H2O. So this is nothing but bleaching powder. Okay, there may be a possibility of asking the question on the composition of bleaching powder. What is the composition of bleaching powder? The composition of bleaching powder is calcium chloride, calcium oxychloride, calcium hydroxide plus small quantity of water. Hydrated molecule is the hydrated molecule. The bleaching powder is obtained by treating with the slacked lime. Slacked lime is calcium hydroxide. Okay, please remember the name of the calcium hydroxide is slacked lime. Okay, or lime water. When lime water is made to react with the chlorine, there is a possibility of getting the bleaching powder. Okay, so it is not a balanced reaction. So just it is the way of getting the how to get the bleaching powder or obtain the bleaching powder by treating the lime water with the chlorine. Okay, so this is the another important. This part is not important. Composition of bleaching powder is important for your exam point of view. Okay, so in this part, these two reaction and bleaching powder is the very important concept. Next, chloride or chlorine has ability to react with the aluminium. When aluminium react with chlorine, it gives AlCl3. Correct? Okay, it has ability to produce AlCl3. When phosphorus react with the chlorine, phosphorus trichloride or phosphorus pentachlorides are produced. Okay, so this is the reaction. When white phosphorus is made to react with the chlorine, use phosphorus trichloride or phosphorus pentachloride. Next reaction is chlorine has ability to react with water. When water is react with the chlorine, okay, so HCl3, hydrochloric acid, hydrogen chlorates are produced. 2Cl, 3 into 2 in presence of oxygen. Next, chlorine react with sulfur dioxide. It is important. Okay, please note it down. This reaction is important. Here this one is important. Here this one is important. So sulfur dioxide react with chlorine. It gives sulfuryl chloride. SO2Cl2, nothing but sulfuryl chloride. So these are the different reactions we observed under chlorine. So this reaction is again important part under sulfur dioxide also. That part we studied in the last cases. Okay, here we use the sulfur dioxide. Water react with chlorine, presence of sulfur dioxide produce hydrochloric acid. If sulfur dioxide is used excess, there is a possibility of getting the H2SO4 also with that. Okay, So these are the different combination reactions are there. Okay, so these are the different types of reaction come across the chlorine. Okay, so not only this one, next the chlorine is ability to convert the ferrous sulfate into ferric sulfate. Okay, chlorine has ability to convert FeSO4 ferrous sulfate. When it is react with chlorine, it gets converted into so-called rice. Okay, this one is ferrous because oxidation state of Ap is +2, here it is +3. Okay, next ferric chloride or this one chlorine oxidize the iron from +2 to +3 oxidation state. So this is the important oxidation property of chlorine. Chlorine has the ability to oxidize the ferrous sulfate into ferrous sulfide. Sorry, ferric sulfide. This one is ferrous sulfate. This one is ferric sulfide. Okay. Next, chlorine, liquid chlorine, or when chlorine gas is dissolved in water, then liquid state of chlorine shows bleaching action. Shows bleaching action. How? When chlorine react with water without any catalyst. The last case we observed with the catalyst. Without any catalyst, get converted into HCl, hydrochloric acid, plus water. Sorry, plus nascent oxygen. This nascent oxygen react with colored compounds, organic compounds. React with nascent oxygen, it become colorless. Therefore, it shows a good bleaching action. Okay, there may be a possibility of asking the question here also. Give the justification for the bleaching action of chlorine. Chlorine is a good shows bleaching action whenever chlorine is made to react with water or in aqueous chlorine act as a good bleaching action because it gives nascent oxygen. That nascent oxygen oxidizes the color component to colorless. Okay, what are the things happen in this case? The nascent oxygen react with colored compound or oxidize the color compound into colorless. Okay, so this is a very important part. Okay, now what happened during the washing of a cloth? If we use small quantity of bleaching powder, it is nothing but a bleaching powder. Okay, when it is dissolved in water, it produces chlorine. Okay, it contains chlorine, excess of chlorinating agent. The chlorine water is produced. Chlorine water contains acid as well as nascent oxygen. The nascent oxygen oxidize the color component to colorless, and this hydrochloric acid, it dissolves many substances so that it acts as a good bleaching or shows good bleaching action. Suppose we use excess quantity of chlorine water or excess quantity of bleaching powder, then what happened? Excess quantity of chlorine is used, excess quantity of acid is produced. That acid burns the cloth so that holes are produced if we use the excess quantity of bleaching powder during washing the cloth. Okay, so these are the general things or general chemistry. Okay, so these are the reactions we observed under chlorine. The several reactions are there. Okay, you just study this much. Okay, it is enough for your exam point of view. Okay, next is uses of chlorine. Chlorine used to preparation of many compounds or gases, the positive gases. It's nothing but OCl2, okay, OCl2, positive gases, tear gases, okay, these are toxic, okay, positive gases are toxic, it has ability to oxidize or decrease the oxygen concentration, okay, so that would act as a toxic. And tear gases, so it produce water or watery ice is observed when gas is touched to your eyes, okay, tear gases. Okay, there are several compounds are produced from the chlorine, and chlorine is the good bleach, shows bleaching action, therefore it is used to cleaning of different components, and it is used in paper industry for because of this bleaching action it is used in a paper industry, cleaning the wood pulps and all that, or oxidize the wood pulp and all that. Okay, and we observe several reactions, so that indicates we use it in our laboratory for the oxidation purpose and all that. Okay, so these are the uses of chlorine. Okay, so these are about the chlorine. In the next video we will discuss the another compounds of halogen, nothing but hydrochloric acid. Thank you for watching.